Alright, once more good evening everyone and welcome to Krazifizix, and you can see it all displayed on the board. Tonight we are looking at electrostatics, and this is going to be the first lesson. It's not something we can finish in one lesson. Grade 11s, you would notice that the poster says grade 11 and grade 12. I'd like you to know you'll be doing this again next year. Not in class per se, but it is question 7 of your final paper. So whatever we are doing now, it's very, very important because you need it for 2 years. So please take note of that. Those of you that are in grade 12, you're lucky you have such a session to help you quickly bring perspectives together on what you did last year. Please feel free. If there is a question you want to ask, you will be allowed to type your question, right? Then we can pick it from the screen and then help you answer. Make sure that you get all the information that we share tonight. Like I said, it's probably going to be a 2-3 night kind of class, but we're going to do as much as we can to assist you. All right, we have a few resources in case you are interested. We have a few resources. That's our grade 11 workbook, and that's our grade 12 Krazifizix text and workbook. The grade 11 is just the workbook that allows you to do a lot of activities after every topic. The grade 12 is a textbook on its own, and it has worksheets in it, quite big, but very, very resourceful. The grade 12 one has produced quite a lot of distinctions in the few years. All right, now when we look at electrostatics, this is what we should be able to do at the end of this topic. So some of you might need to take screenshots as fast as you can. This is what we should be able to do. Number 1, we should be able to state Ohm's law. Number 2, we should be able to solve problems using that formula in 1 dimension, all right, and also in 2 dimensions. We're going to have 2 charges, we're going to have 3 charges, both in 1 and 2 dimension. And that's where I'm going to actually focus on for the first lesson. In the second lesson, then we'll be looking at how to describe what an electric field is, to draw an electric field pattern, all right? That we cannot look at tonight, but we'll look at that in our next lesson. We should be able to define electric field at a point. We should be able to do calculations of electric field at a point as well, all right? And we restrict to 3 charges here and there. Okay, all right. So that is our objective for this lesson. At the end of this lesson, please take a screenshot. Take a screenshot, because at the end of this lesson, you need to be able to tick through that, yes, I can do this, yes, I can do that. And if there is anywhere you're having doubts, get to your teacher at school. They will be able to help you. Get on the group. We will be able to assist as well. So please take a screenshot and use it as a checklist. The second half screenshot. Beautiful. All right. Now, let us begin with the classes. So we are looking at electrostatics, okay? We're basically looking at electrostatics. And when we talk about electrostatics, from grade 9, we talk about charges, all right? We talk about charges. Good. We talk about charges. So electrostatics. I'm going to be asking a few questions. You just need to type in quickly, as many as people can type in whatever you think the answer would be. Electrostatics. All right. Now, when we talk about electrostatics, we're basically talking about charges. And we know that charges can actually be divided into two. There are two types of charges: positive charge and negative charge. The positive charge are actually known as protons. We know that from our atoms, right? And the negative known as electrons. Very key. Positive, protons; negative, known as what? Electrons. We can also measure the quantity of charge. All right? We can measure the quantity of charge. We can measure the quantity of charge. And when we say quantity of charge, we are going to use the letter Q. Quantity of charge. And this is measured in coulombs. And this is capital C. So Q represents the quantity of charge, and C represents coulombs, which is the unit of the quantity of charges. So already we said there are two types of charges: positive and negative. The quantity of charge on each of these can be measured. I'm going to go through your formula page right now quickly for you to see the quantity of charge. All right, I'm sure you are used to this page. Look at the charge on an electron. You would see the charge on an electron there. It is negative 1,6 times 10 to the power negative 19. Why negative? Because it is an electron. Electrons are negatively charged. What is the charge on a proton? A proton is positive. So instead of having negative there, a proton will therefore be 1,6 times 10 to the power negative 19 coulombs. I hope you know where to get that from now. The charge on an electron is the same charge on a proton. The difference is just that electrons are negative and protons are positive. I hope that is okay. So you have a formula page, whether you're in grade 11, whether in grade 12, you have a formula page where you can pick that value from. And you would see how we will then use these values as we go on when it comes to calculations. All right. Now I'm going to go to the next thing, which is to talk about the behavior of charges. Most of these things are still grade 10 and grade 9. Behavior of charges. Okay, behavior of charges. And that's very simple. Number one, we're going to talk about three of them. What happens? Like charges will do what? Can somebody please type in the answer for me? You did that from grade 8, natural science. What happens to like charges? Type in the answer. Oh, beautiful. Thank you. I have Lindo, Yongama, I have Ofense. You guys are the best. Nampumelelo, beautiful. Beautiful. Like charges, awesome. The doozy doctor. Like charges, repel. So when you have two positive charges coming together, they repel. Thank you, Matlati. And automatically, what would happen to unlike charges? I'm sure it's obvious now. Unlike charges will do what? Will attract now. If I take you back to my home page where I started this class from, let me take you back quickly to my home page where I started this class from. You would see Thank you guys for answering. Grade 11, that's what we do. We answer. You just type a message. Can you see that thing playing there? You have a positive and a positive. Do you notice it's moving away while the negative is attracted towards the positive? So like charges, positive and positive will do what? Repel, pushes the other one away. But a positive and a negative will do what? Will attract. I hope that makes sense. Behavior of charges. That's number one. Number two. Number two, behavior. Charges can be transferred. Charges are transferable. And when I say charges are transferable, I'm talking about electrons. Electrons are transferable. They can move from one object to the other. Alright, electrons are transferable. They move from where they are more to where they are less. They move from where they are more to where they are less. Electrons are transferable. They move from where they are more to where they are less. That's very key. They move from where they are more to where they are less. I hope we're okay. I'm going to give us a few examples right now. Let's check something here. If I have A and B, and we are going to prove this as we go on. If I have, guys, please note, this is wrong. 5 columns. This is wrong. 5 columns. Is it a sort of electron diffraction? It's just electron transfer. Alright? I would rather use electron diffusion rather than diffraction. Diffusion. Alright? Please take note. Charges have either, remember we said charges are either positive. Let me take you back. Charges are either positive or negative. Guys, please note what I did here on purpose. It is wrong. What is wrong with this? There is no sign. We need to know whether it is positive or it is negative. I'm going to be very slow when I introduce, guys. I'm very slow when I introduce. Positive or negative. What does a positive charge mean? I think I need to actually do that. Let's explain what a positive. If I see a positive charge here, what does it mean? It means it has more protons than electrons. More protons. Okay. Still trying to sort out a problem here on this board. More protons than electrons. But if I have, look at this one here, negative 2 columns, it means I have more what? Electrons than protons. I hope it makes sense. The fact that there is a positive here means I have more protons than electrons. Protons are positively charged. But if I have a negative, it means there are more what? Electrons than protons. Now my question would be one. My question will be this. Let me make a note before I ask you a question. When charges are brought close in contact to each other, when charged bodies are brought close or are brought in contact with each other, charges move. When I say charges, we talk about electrons, right? Our focus will be on electrons. Charges move from where they are more. I'm repeating that information because it's important. Where they are more to where they are less. Charges would move from where they are more to where they are less. Now, look at the value of A and B. Look at the value of A and B. Where do you think charges would move? Will they move from A to B or B to A? I have A and I have B. Brought together, this is positive 5 columns and negative 2 columns. When they are brought together, where will charges flow from? Will it flow from A to B or B to A? Guys, I need as many answers as possible. Victor, your hand is raised. Victor, your hand is raised. Do you have a question? All right, I have answers already flowing in. A to B, B to A to B, B to A. Come, guys. I need as many answers as possible. A to B, B to A, B to A to B, B to A. All right. Okay. Quite a number of us are saying A to B, and I think the class is divided into two. I don't know which one is winning though. A to B or B to A. Good, Nicolene, you're here. All right. Remember what I said? I said that positive tells us there are more protons than electrons. Negative tells us there are more electrons than protons. In this case, there are more electrons in B than A. That's why the negative. I'm sure the numbers here was deceiving you, thinking that no, the charge is here. This one has more protons. More protons. While this one has more what? Electrons. So charges will move from B to A. Electrons would move from where they are more to where they are less. They are more in B, that's why it is negative. And they are less in A, that's why it is positive. We have more protons than electrons. Are we okay here? I'm going to give about 4 examples so that we understand this from the basics. If you are lost, please let me know. I have C and I have D. I have positive 5 columns and I have positive 2 columns. Will they move from C to D or D to C? Will charges move from C to D or D to C? I'm reading your answers. I'm saying D to C, C to D. Okay. Eleonora, you said C to D. Where do we have more electrons here? There are more electrons in D than C. Thank you, guys. There are more electrons in D than C. C has more protons. You can see the positive 5. There are more electrons. Okay, let me just assist someone. All right, my answer would be from D to C. There are more protons here. Here there are more electrons. You can see this number here. There are more electrons here. This number is actually close to 0, which goes to the negative side. So there are more electrons on D. It is closer to the negative, while this C has more positive. All right, let's try another one. E and F. Minus 2 columns and minus 4 columns. Where will they move from? Will they move from E to F or from F to E?